Hi everyone. In the earlier video, we saw that the background colors are getting distorted like this character H and O, right? So that's what we will try to fix it in today's video. Okay. So now I will stop this. I will go back to this EDK2 and I'm going to use this HII font protocol. Okay. So now let's include this protocol here. HI font. Okay. So now let's include this header, which is this HI font protocol as well as a starting. HII font, and I will initialize this to null. Okay. So now let's initialize this MHII font. Okay. So now I will come to our entry point, which is here. Okay. So to avoid the time, I will try to copy paste this, and here this will be MHII font. I need to use the GUID, right? So let's use the HI font protocol GUID. Okay. So if this HI font is not available, then I'm going to return. Okay. So now let's create one char 16. Okay. So let's say I'm going to call this as text to render, and I will initialize this text to render as the same text which what we have used earlier. Okay. So which is the cell sample random test. Okay. So now I'm going to create a function which is going to return a status. Okay. Assume that function name is render text, which is going to accept the same arguments as the print char by char, and y-axis probably I'm going to make it as 100, and then I'm going to pass this render text. Okay, and then if there are any error, then I'm going to return it from here. Okay, so now let's create this function. So here what I'm going to do is if underscore status, and then input uint uintn. So this will be a start x, and then uintn. Then this will be a start y, and then I'm going to include the character 16 as string. Okay, and then by default, what I'm going to do, I'm going to return ef underscore success. Okay, so let's format the document. Okay, so now first thing what we need to do, so we have to check whether this string is null or not, right? So if string is equal to null, so then return ef underscore invalid parameter. Okay, and we need to calculate the length of this string, right? So what I'm going to do, so I'm going to create a variable called a string length. Okay, then let's calculate the string length. So string length is equal to strlen, and then I'm going to pass the string as a input argument. Okay, so now I need to iterate through each and every character. So I'm going to create a uintn as an index. Okay, so now here what I'm going to do, so I'm going to create one a simple for loop to iterate through each and every index. Okay, so now let's create one for loop here. Okay, so now I will align the document. Okay, so now for every character, we need to get the bitmap image from this protocol, right? So I'm going to call this get glyph. So this get glyph is going to return this EFI image output, which ultimately contain this bitmap, and this is what we needed. Okay, so let's create this. Okay, so this I'm going to call this as star um, char pixel. Okay, or maybe suppose say it's an image blit, right? So I'm going to call this as an image blit. Okay, and every time what I'm going to do, so this image blit I'm going to initialize it to null. Okay. So now let's try to call this function, right? So here status is equal to HiiFont. I'm going to call this glyph, and it is going to accept some bunch of argument. So let's split screen. And here the first one is this operator. So let's have this status variable defined here. F underscore status as status. Okay. So first argument is this operator. So I'm going to pass that. And the second argument is a character. So let's pass this. So we have this string of an index, so which makes sure that it is going to pass one character at a time. And then this string info and the baseline is not needed for as of now. So I'm going to make it as null. And then the blit we have to pass, right? So that blit is nothing but our address of the image BLT. Okay. And the baseline is not needed. So I'm going to make it as null. Okay. So now if there are any error in the status, I'm going to return status. Okay. So now we got the bitmap characters of bitmap structure of that character. Okay. So now at the same time, we need to know where we have to render that text, right? So so we need some buffer to hold that information. Okay. Then what I'm going to do, so here I'm going to create one display buffer. Okay. So let initialize the display buffer as the horizontal resolution into vertical resolution. Sorry, it should be how much buffer we have to allocate, which is our height of each pixel or each character, right? So each character will be our glyph height and the glyph width, and then we have to allocate the size of this pixel. Okay. So now let's get the display information. Okay. So means we have to read the content where we have to display. Okay. So here I'm going to call this blit function, and I'm going to pass the display buffer, and I'm going to start with the x, and then every time I'm going to keep on incrementing the width, and the y remains the same. Okay. Like for example, assume this is my display. Okay. In this display, assume this is a placeholder where I wanted to display the character. Okay. So now first I need to read this buffer, correct? So now assume this is a place. So now if I expand this box, okay, so now assume this one. And this will be having multiple rows and multiple columns, correct? Okay. So now what this function is doing, so what this function is doing, so it start with this x, which is this position. Okay. So it start with here. Okay. And then it will go through index, right? So which index is in our case for the first loop, index will be 0 into width is 0. So 0, 0 is 0. Which means first it is going to read this pixel. Okay. At this y position. Okay. And then the next time it is going to read this pixel, and then it is going to read this pixel, and then this one, this one, this one, and so on. Okay. So now that's what we are doing here. We are going to read that information which is stored in that pixel. Okay. And then once we have that, then let's create one temporary buffer called the character pixel where we have to render. Okay. So here I'm going to create this as a character pixel. So this character pixel is a one which we are going to render back to the screen after the manipulation. Okay. So now let's define two variables to scan through each and every pixel. So this will be, first we had to scan through the height, and then we had to scan through the width. So which means index 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and then 1, 0, 1, 2, 1, 3, 1, 4, like that. Okay. So for that, what I'm going to do, so untn, so x comma y. Okay. So now I will come down and I'm going to create the double for loop. Okay. So now first I will start with a height. Okay. And then I'm going to start with a width. Okay. So height will be part of the x and the width will be part of the x. Okay. So now Here, we will scan through one pixel at a time, and then we will read that information, and then based on that, we will decide whether the bit manipulation is needed or not. Okay. So now here, now I'm going to create another variable to make use of the calculation. Okay. So here, uint n, I'm going to create this as a row, um, start index, and then pixel index. Okay. So which row we are working on and which pixel we are working on. Okay. So now first we need to calculate which row we will be working on, right? Whether it's a first row or second row or third row. Okay. So now let's use the row index first. Okay. So now row start index is equal to y into EFI glyph width. Okay. EFI glyph width. Okay. And then we need to calculate the pixel index. Okay. So this pixel index is nothing but our row index plus our current x, so whatever we have. Okay. So this will gives us which pixel we are working on. Okay. So now what I'm going to do, so I'm going to create another a temporary buffer similar to this blit pixel. Okay. So this I'm going to call this as a current video buffer. Okay. So which buffer currently we are working on. Okay. So now here current video buffer. Okay. So before we initialize the current video buffer, we need some pixel information to be stored, correct? So I'm going to create another character, which is this pixel char. Okay, so since we have the pixel char already, so we can use this. Okay, so now let's initialize this char pixel here before we start our loop. So this char pixel is nothing but, okay, so EFI graphics output BLT pixel, and which is nothing but, so where we have to read this, we have to read this from our image blit, which is coming from the HiiFont, which is image dot bitmap. Okay, so ultimately we are going to read this bitmap. Okay, so now once I read this character, okay, so now that character information, what I'm going to do, so I'm going to use it in the current video buffer. Okay, so now current video buffer, what I'm going to do, so this current video buffer will be, I'm going to take the address of this display buffer of this particular index. So which means from this display buffer, which is coming from the screen, which is this one, right? So I'm going to read this information, and that address, I'm going to store it in this current buffer. Okay. And then what I'm going to do, we have this char pixel, right? Which is that a text representation, right? Assume here I'm going to create another box, and by default it will be in the black color. On top of that, there will be a gray color text. Okay, assume like this. Okay, so now this will be splitted into like this, right? So now here. So now I have to compare this pixel versus this pixel. Okay, to check whether this character is a gray color or not, whether this pixel is a gray color or not. If it is not gray color, then I'm going to use this one. If it is a gray color, then I'm going to replace this gray color with a white color. Okay. So now here, what I'm going to do, I will check whether my current this character pixel which I'm working on, whether it's a gray color or not. Okay, so that gray color is our RGB is 98, 98, 98. Okay, so if it is a gray color, then I'm going to override those pixels, right? Which is which is our current pixel, right? So if it is a gray color, I'm going to replace that gray color with a white color. Okay. Else, if it is not a gray color, which means it's a background color, so that background I have to read it from my current buffer, which is coming from the display. Okay, so then what I'm going to do, so here I'm going to use this current pixel. of that index, I'm going to give the simply I'm going to assign this current buffer pointer. Okay, so which means this if statement will make sure to print this characters a as is by converting that gray color to white color, and this else statement will make sure to read the data from this buffer. So this will make sure that those pixels will not get distorted. Okay, so once I have the pixel information in this char pixel, right? So simply what I can do, so this pixels, whatever this data, right? So this data I can write it back to here. Okay, so let's do that. Okay, so what I'm going to do is I'm going to use the blit call. So outside of this for loop, okay, I will align the document. Okay, so now what we are doing, so this character pixel is the one which we are filling, which is a buffer, and we are trying to do it to we are filling it to video. Okay, and in this buffer I'm going to start with this 0 comma 0, which is here. I will show in the red color here. Okay, and then I'm going to start with this x and y, and every time I need to increment this width, correct? So that width I'm going to increment. Okay, that's what we are doing this here. Okay, and it will be a size of our character. And once that is done, I'm going to free pull that last buffer which is been allocated, and then I'm going to return the status. Okay, so now let's see if we are calling this function. Here we are calling, so now let's try to build it. I will open the command prompt, EDK setup, build. Okay, and let's wait for the build to complete. Okay, build is completed. So now let's run our WinHost. Cop sample driver. Now we can see a clear text. So probably what I'm going to do, so I'm going to take the snippet of this and then I can show you the enlarged one. Okay. So now we can see, maybe I will take this color. Okay. So now this is the previous video. Okay. So now this you can see this is our current video. So there is no distortion. So we are printing the white color by making sure that the background color is not getting distorted at the same time. Okay, so in the next video we will enable the mouse pointer again to make sure that these pixels are not getting erased. So that's it for today. Thank you.